Okay, we'd like to capture, no, what we'd like to do here is break this baby down into a single resistor so that we can figure out the power that's dissipated by this one here, the 5 ohm resistor. There's just no way that you can do this right now. We know that there's a 25 volt source, and we know that there's 4 resistors. You can tell nothing out about this one right now. Okay, so what we need to do, break it down. Draw a diagram every time you make a change. So these two are in parallel. So I'm going to go 1 over R is 1 over 30 plus 1 over 30. Remember, 1 over 30, that just turns into 15 ohms. I'm going to redraw that. 10, 15, oops, and there's my 5. 10 ohms, 15 ohms, and 5 ohms. That's all in series now, so I'm going to go 10 plus 15 plus 5. So my total resistance is going to be 25, 30 ohms. So I'll redraw this again. And 30 ohms. Okay, you may want to keep a second color of pen handy, because what we're going to do now that we have this is we're going to work backwards so that we can find out all our information about this. So let's see here. I know that R equals V over I. So then I know if I have total R, RT, well, that's got to be my VT, oops, VT over my IT. So I can find my total current here. So that's going to be IT is going to be equal to VT over RT. So that's going to be 25 over 30. So my total current is 0.83 of an amp. That's important. I'm going to write that down in a different color. 0.83 amps. Written in red because now I use my circuit theory. I know that these are in series, and I know that current is equal in series. So I know that this is 0.83 amps, this is 0.83 amps, and this is 0.83 amps. I know that, as well as I know that up here on this one it's 0.83 amps, and I also know that this one is 0.83 amps. And for here, this 0.83 amps is splitting because of this junction, but I can figure out what my voltages are there. I can figure out what my voltages are here. I can figure everything, but you know what? I don't need to go that far because what I'm trying to do is find the power right here. And I have R and I have I. Well, power, the formula is I squared R. So if you know that right off, you can stop right here. That's going to be 0.83 squared times 5. So your power then is going to be 0.83 squared, 3.44 watts. There you go. And that's the power that's dissipated on this resistor right here, which is the same as this resistor right here, which is the answer that we just found, 3.44 watts. Now, just as an aside, remember, power is voltage times current, V squared over R, or I squared R. We chose this one. We could have gone further and found our voltage here, and we could have used V and I, or we could have found our voltage and gone V squared R. All of those would give you the same answer, but you might as well do the quickest way possible. So there you go, power dissipated in a circuit.